Hello everyone, this is Brady. So today we're going to replicate a kind of a Houdini effect inspired from the tutorial. This effect is called recursive subdivision. And this noding, this live noding is being voiced instead of not being voiced. The reason is that this workflow, if you have watched the tutorial just by several minutes or whatever, you will realize this workflow is extremely tedious. Extremely tedious, and it probably will be even more tedious if I'm doing animation nodes. But I don't know, there's nothing really special. So just in case that in the future I'm too lazy, I don't want to make a tutorial out of these things. I'm voicing this live noding. So I think let's just start right away. So firstly, let's briefly talking about the plan that we're going to have. So goes to the top view. So we have a square, so let's just make a square. This is a nice part in Blender that we have annotation, because the original tutorialist made a demonstration in the Photoshop, whatever. So we have this square. I'm going to hit points, and this point and this point. I think this is it. So let's take this point. Basically, we have 3 cuts. So now we have 4 squares. And once we connect these 4 squares, everything becomes independent polygons. And then, how should I say? And then we doing a kind of recursive effect and basically do the same with in these single polygons and so on and so forth. Okay, this is kind of very simple. So always starting from the most single element, we have a square. So we're going to use, instead of using the plane that we have, because it's very nice we have a directly grid, and we can use mesh object output to actually look at the grid that we created. The reason I'm doing this is actually I would like to determine the size, because I do not want a 10-10. So 1-1 I think is fine. 1-1 is too small. Take a 2-2. Yeah, this is the correct. So direct our original plane. We are not actually going to use the target at this moment, because we are going to do things more kind of blindly. I'm going to take a mesh info so that I can actually determine the points from point to point. And then we have to basically get kind of points in the middle. So this is very tricky part. We need to get S element. This is going to be extremely tedious, as I said earlier. So we get the first point. We know the first point here. Basically, in computer graphy, everything is how should I say? The order of the mesh generation is very different from what we usually think. I think the mesh generated in the way that the 1, 2, 3, 4. This is how it generates. It does not go in the order. Yeah, and this is exactly what happens. And the index always starts from the 0. This is how computer works. So we have the first point, we get the first point, we need a second point, and we basically duplicate these several things. Actually, I like scripting instead of in Houdini that you type a script. But if you type script in Houdini, it's also, there's more freedom, but I still like nodes. Even if you end up taking a lot of nodes, I still like nodes. And then we're going to use mix vector. So just to say that I think we're going to do things a little bit different from Houdini. Actually, not really different, because it's the same principle. And by changing this factor, where's my factor? Oh yes, we forgot to change the index, so we're having the same point all over the place. Okay, so now by changing these factors, we are basically mixing these 2 vectors in the middle, so you can cut whatever place you want. You can actually add a random within this factor. To actually change out some things. In case that my point is going to be beyond this place, so I'm going to take a clamp, and then I'm going to take another clamp. Yeah, actually, visual scripting is much better than typing the script, because you just connect the place. You just connect all this kind of how should I say? You just connect all this kind of linkage instead of typing things which copy paste going to 100 lines of script. Yeah, I really like this when it's not working. So we have this. Yes, so we get a second cut, okay, and then we need a third cut. in which I think these the 3 and the 4. Where's my 3 and the 4? Yeah, just actually I do not really know which one is which one. So yeah, now we actually get that. So take a green color just for better visualization. Okay, so now we have all these kind of points, and then we need to connect all these kind of points together. Again, this is really tedious, but I think it's much better than Houdini that you have to write thousands of lines without knowing what's actually happened. So next step is basically to connect all these kind of polygon. Actually, we need to create another point because we need to create a kind of intersection here and there. So how do we actually do that? We are going to actually, this is kind of tricky. So I have these points. This is the white points, and I have the red points. This point x-axis should go with the. So let's take a separate vector and separate the vector. So basically, I have the plane here and the point here, the axis, and then we are going to combine x, y, combine vector. So you can see there's actually lots of points being created. I think this is it. Let's just duplicate our 3D viewer to see what it actually generated. Ah, no, it's not right. This is not the right place. Oh, because I reverted. I need to revert everything. Okay. So I take the So the y-axis, x-axis. Yeah. So now we get the correct answers. Just to take a more kind of colorful, better visualization. Okay. So once we finish the one, we're going to get the second. Oh, this is actually easy. Much easier than typing facts. Oh, this is so easy. Let's take these. So we have this, and then we combine vector. Take the. I actually do not know which one's which one. It's just the. So I think it's the second point. Wait, where's our second point? So the red points. Actually, I'm getting confused. So we have the red points, the x-axis. So we have the red points from the x. Actually, I do not need this. I can directly plug this. Okay, the x-axis from the red points, and then the y-axis from the green points. Take another viewer. Okay, so we have this being done basically. So let's try to think again about yes. So now we have all the points that we need. We just need to connect all these kind of places, just so you know the order of everything. So I think this is a little bit. It's again going to be a little bit tedious work because we need to combine the vector list in the way that the computer understands. So we'll combine. Create a vector list actually. And we need at least 4 points. So I really think this is better than facts in which you type script, because you just need to know which point is which one, and then to decide, oh, well, how should I actually linkage be informed? This kind of look is kind of ugly, but we have all these kind of points here. So let's increase the place. We do not need the outliner. Okay, so once we have this, I need to go with the first point, which is the white point. So drawing the polygons here, okay? And the first point from the white polygons. Second point is my second vertices. And then the third point, because computer graphy always works in this kind of weird zigzag way, not the clockwise way. So we need a third point, which is our blue. Yeah, we know the blue. Oh, this is so nice. And then we need a red. So we'll create the first 4 vector list. It's fine. So that we can actually take a little 3D viewer just to see if we're actually working. That's right. I actually will run out of the color. So now we have these 4 points. Okay, very nice. We do not know if it actually forms a grid or not, but I think we will just we can definitely try. Just put this kind of grid. Do I actually use the same grid? So how to actually create a grid? We're going to take a mesh info. and we're going to combine mesh. Actually, you can use the original meshing for the created from the beginning, but I do not really run up these entire trees. So we have this, and then we're going to combine edge indices and the polygon indices, but we're going to replace the vector. So now we have a new polygons being done. Oh, this is so nice. Okay, so we have done this. We know our concept is going to be correct. Next thing is just to keep doing for the all polygons that we can do. So we have another. I'm going to delete this 3D viewer because okay. Once we have done that, the second polygons, it does not really matter which polygon we actually start, because it's just does not really matter. So a second polygon, I think I'm going to work with this larger one. So we start from the pink, the pink vectors from this here, and the red vector from here. And then is the green vector, and then is the fourth. Where's my fourth? Fourth is the last. Okay. Then next polygons is this tiny. So we start from the red. Actually, oh, actually, we need to create one more vector. I forgot the vector there is a vector which should be here. Okay, so this vector is basically the red. How should we actually define this red vector? I think it will be the same. Let me think. Okay, so I think it will be the same factor, but between the 1 and 3. So we have the index 0, and I have the index 2. Try to see how the viewer comes out. Yeah, this is it. So red applies to red. Just to make sure that these two vectors should be the same. So let's take a value, float input, and take that 0.4 to connect these two, so that you know that these two are sort of synchronized to each other. And because the blue points is also linked with these kind of things. So this is kind of procedural that you just slides over. Okay, so this is good. So now we have our new red points. Let's change that to color kind of dark red. Actually, we run out of color. What can I do? Okay, let's take a cyan color. Then you put the cyan into the first socket. Then we have this pink. Then we have the green. We have the green, and finally we go to the third, which is index 2. The node tree, you do realize it looks kind of very ugly. There's no way that I can fix that. You can organize in your free time, but I don't think it will improve anything. But I think this is really nice because you can actually see from all this kind of color about which one is which one. So finally, there's a last polygon that we need to work with. We start from 1, which is index 0. Then we are having these white dots. Where's my white? Yes, this is white. And then we are having these blue dots. Blue. Oh, actually, we go to the wrong order. The blue should go to the last socket. The third socket should be this cyan. So really be careful with this, with the order, because if you by any chance made a mistake. Did I actually make the mistakes earlier? So we start from the cyan, then we get the pink, and then we go to the third socket. Actually, yes, this is the green should goes to lower, and the third should goes to the second. So just to make sure that you really take every polygons to the right place. So this is the second polygons. Then we have the third polygons, and then we have the fourth polygon. Okay, we basically have done this basic setup. It's kind of really ugly in Node tree, but trust me, I think this is much better than Houdini Vex. So we have all the polygons. Then we need to form 4 polygons. Actually, let's just what do we do is I have this mesh info and I have these combined meshes. I just duplicate for 4 times, and then I'm just going to take these edge indices to all the places. Edge indices 1, edge indices 2, edge indices, and take another edge indices, polygon indices. So once we have that, we just fill out the entire vector list that we created. So here, and here, and take the data forth. So finally, we have a lot of mesh. This is kind of also a tricky point because we would like to combine this mesh together. So join mesh list, actually create a mesh list. So we need to create this mesh list together. Well, animation node is an older system, so it does not really support a kind of geometry nodes like, oh, you have a socket that accept as many as possible. You just have to do this kind of process. And then take that to mesh. We have a we're supposed to have our polygons being generated, but something's wrong, does it? Which part is wrong? So we have the first, we have the second, we have the third. Oh, where's my third? Oh, what happened was our third polygon? Oh, and we have forgot to actually link these polygon indices. Okay, now it almost scares me about what's wrong. So we have our cube backs. Okay, I'm going to remove everything here because we no longer need each of this. I think I'm going to keep the color code. Actually, you do not need this color code. I'm not sure to disable that or keep them, because I do not think we need to use this anymore. So now we have these cubes, but it's actually subdivided. I think just notice that we have this factor that's actually control all this kind of stuff. So just to give you kind of idea, previously we have discussed, and we have this port. Okay, this is really important. So please remember how procedural this is, because we are really going to fix this. So once we have this, I think the next step, let me think. We can add a noise at this moment. For example, you can use the number wiggle. Number wiggle is actually kind of a very nice one. Amplitude will be 1. I'm not sure if the amplitude 1 is, so they try to change the evolution. Yes, amplitude 1 means we have the positive 1 and the negative 1. So we need to take a map range so that to clamp everything from the negative 1 to positive 1. So this is what happens with number wiggle, and we can wiggle within this factor, and we also have another factor just to remember this. So in this case, this we have multiple factor actually. So how can we actually deal with this? There's multiple ways, like you can create a list and get a list element 1, 2, 3. 3 numbers. There's also, I think I'm just going for a easier methods in which we're going to duplicate this number wiggle for 3 times so that we have 3 vectors. Okay, so it's the good part of this number wiggle node is that you duplicate a node, it will automatically create its own node seed beyond the normal seed that we can control, so that each node, each noise will be really different from each other. So it's just plug that 1-to-1 factor, and we have this second factor. And also a good part of animation nodes is that if you had nodes, you can have the inputs, while the Blender nodes does not support these things yet. So then we put this second into the place, and then we put the third into place. So now we have 3 whatever stuff. I think this is fine. because yeah, everything is just a procedural. Just make sure they clamped. Okay, so I think this is good. So now we're just working with the basically how should I say, a single polygons, and then we're going to do the recursive function, which is going to be tricky. So we'll take a loop input, and we're going to always start from the same grid mesh. But I think this grid mesh, I will put that to parameter because I would like to minimize everything from the loop. Also, I'm going to output the mesh list. So this is the loop that we're going to have, this entire functions. And I'm going to take the hit W goes to write, create an invoke node. I'm going to cut this linkage and take that to the mesh. So I'm going to set the iteration to 1 so that we'll just cut the entire things into one time. And take another mesh, it will automatically join the mesh list. So we're supposed to create a target, put the mesh into place. So this is what we're getting at this moment. But to do the recursive function, we need to run the recursion. So we need how should I say? Let me think. I think I'm going to create another mesh. Is that a mesh list or mesh? Actually, I do not know. Is that a mesh list or mesh? Actually, this is a tricky part. Because it more feels like I need an iterator. The whole point is that once I divided these planes into 4 parts, I need to put each 4 planes back into the entire loop. So I need a actually iterator, is not a parameter for each of the polygons in the future. Which means we actually need 2 loops, do we? This is a tricky part. So I'm going to take a mesh list. So basically we're going to work inside the loop actually. So I think this is what we're going to do. So we always start from the grid. This has no doubts. But our new grid will be overwritten. Okay. So I get the idea. So we start from a mesh list in the iterator. But basically, we need 2 loops. So the mesh info goes to the second, because we always works based on the inner polygons, the actual polygons we generated. The second list is just to provide the information about the edge indices and the polygon indices. You can definitely use the same one. Just I don't want to. This node tree is already ugly, that I don't want to this area to be touched with that area. So just make things a little bit clean. This was my intention. Really not the idea. The first is really the input mesh, and the second is a reference for indices. Okay. So please don't be confused with these several concepts. So next step is we're going to have the this is going to be crazy. So we need to create another loop outside. So So we take the recursive function outside. So we have here generating all this kind of mesh list, and I'm going to take this mesh list back to the loop. This is the recursion that we're going to make. So I'm going to take a mesh list. This mesh list will go to the mesh list. Okay, but this mesh list will also receive the mesh from the later. So what we do, this actually has been explained in my advanced loop to the advanced parameter or whatever in the loop, whatever. I don't know how to explain. So what we do is take the reassign. Actually, you just need to reassign. So once you take this reassign, what happens is, you put a mesh list into the place, and then after it outputs everything, so you input everything back to the same place. Then this is perfect. We're going to output the mesh lists all together. Oh no, actually this is also not right. Because this is subdivision, we are going to remove the original mesh anyway. So let's take this as a output. And then I hit W, create invoke node. So this is the actual loop that we are running through. For indices, I'm going to take the 4 indices into the parameter again. Take this to place, and then finally for our mesh list, I'm going to take the mesh. Okay, I think this is it. So let's take one. Nothing happens because we do not input anything to this mesh list yet. So here, what can we actually do? We're going to take a create edge mesh, create a mesh list, remove the second point, and we're going to create a switch. So if the index is 0, then it will always show the false. Basically, the boolean works at 0 and non-zero, and the index always starts from the 0. So our first loop always starts from the 0 index. It will be the false. Otherwise, everything will just be the mesh list true. Okay, put that to mesh list, and then immediately, we get our amazing stuff back. Oh, this is so nice. Okay, and this is, yes, I think we have done. So one thing I'm feeling compounded at this moment is I do not really, because it looks like a perfect cube because we do everything perfectly. So I think we're going to do, so let's polygon offset polygons, and I'm going to change the scale vector from value, just to take that to 9.98, and it works. So we created kind of this kind of edge so that we can have better visualization. Okay, then next step is try to observe the miracle, and okay, it does not really work. Oh, why? It works, but it does not really work. So what happens is we have this cube here, and it took the same cubes, and once we go to the second iteration, everything will be generated within these cubes. Okay, which means there's this is tricky because I don't know. wait, where's the problem for real? Oh, because these are the, this is tricky. I do not know the, okay, so I think I actually get the idea. The reason is we join the mesh together so that it does not actually know which mesh or which polygons to actually look at. Okay, so I think the easy way to start with this is we're going to take a mesh list. We can use the same for indices. It really does not really matter. This is awkward. No, I think I'll just be fine. Actually, I do not know. Can I actually put this back? Oh yes, it actually does work. Okay, so we do not need to join the mesh. Just do not join the mesh. Okay, this is fine. So once we have done this, everything has been subdivided. Oh, this is amazing. Oh, this is amazing. The only thing is that everything, because we're using the same parameters throughout. So there is no variation. Okay. So to make a variation is always easy. So there is a preset which is called index seed. Oh, this is so amazing. I like this. Take the loop index so that you can put the index back. I will really explain this index seed at a later date, but it's also very easy to use. So I just would like to put the seed above the 4 indices to make it look a little bit better. And then we take the seed 1, seed 2. You can actually use the same seed. It does not really matter because we have the node seed anyway. And take these. So every time I change the seed, oh, this is amazing. Oh, this is so amazing. I'm actually, oh, I cannot believe we have really done this cool effect. Next step is we are going to take the evolution because we would like to wiggle these entire things. You do realize the effect of wiggle, right? So take this wiggle as effect. What we do is basically I'm going to take a single float because I want to keep as few things within the loop as possible. So I will just put everything in the parameter. I'm not sure if it actually makes improve the performance, but just in case. So once we take this float, I'm just going to take that evolution. Okay, everything is just now 1 millisecond, which is we're still within a very nice range that we can subdivide probably 100 times until it explodes. So we have this evolution. You can put this evolution even back to the parameter, or not to put the parameter. It does not really matter. Okay. Then we're going to take this. I think I'm going to time info. Nothing happens, but if we play the animations, you can see how it starts to wiggle itself. So increase the rate. Oh, this is amazing. So then we take that to 500. And this is how this entire thing looks. Oh, this is amazing. This is so nice. Oh God. And we can increase the iteration. Just remember to really save your progress anyway. So I'm going to save the progress. So here, let's finally let's add this iteration, like 3 to 4, 5 times. Actually, this is already too much, but it's actually okay. The performance is extremely good. Actually, it's surprisingly good. I originally thought it would explode my computer or so, but it seems like okay. You just need to subdivide. Oh, we have everything. Okay. Then this is super extra ultra nice. Oh, this is amazing. Just to know that it's not necessary to be. Actually, we need to work everything based on a grid. So this is for our knowledge that we need to work with grid. But there's things that we can potentially. You can change some parameters for our initial mesh. For example, I think you can change the length, kind of stuff. Because although I said that's 4 indices, but the vertices will be overwritten anyways. So only the edge indices, polygon indices, which is not being affected by the length or rotations. So the whole point is that you can actually manipulate it as you want. You can also change the. I don't think change the subdivision is what you want. Actually, I do not recommend you to do so. Just really be careful. And you do not really need a high iteration because I think it makes things only ugly while the polygon is too small. Okay. We have everything on the grid, but what's really amazed me is that you can turn these grids into whatever things. I think the first important thing is I need a subdivision because we're going to subdivide, rotate. So simple subdivide for 2 times. Then I'm going to take a simple deform modifier. Where's my simple deform? And I'm going to take the take a bend. It does not really work because while you're working with simple deform modifier, you always need to make sure your entire mesh is erected. So we have transform mesh. It's not possible to rotate the mesh and apply the rotation because everything will be overwritten with the animation nodes later. So we need to do this and use axis rotation matrix. We're going to set 90 degree, and then we have to rotate this. Then if you take 160 degree, then we have a cylinder being generated, and you do see the animation. Oh, look at this, how cool it is. Oh, amazing. And the performance is so good. Oh god, so amazing. Oh, I cannot express how much excitement I have with this. Really, I didn't expect this is so easy. And you can decide the subdivide amount. Just to know that if you're working with this kind of shader smooth, because the shader smooth is part of a mesh or whatever, so you need to take a shader object smooth to make sure it actually is smooth. Oh, this is so amazing. And the performance is really nice. Oh, 25 milliseconds, almost nothing. I was expecting it hits like 200 or something like that. But the viewport is really lagging very much. I think because the subdivision or whatever. My computer is slow anyway, so does not really matter. One more thing I would like to add is this is just a cylinder. What if I would like to have, how should I say, a sphere? I've actually shown in other places. Basically, you turn, I think, 180 degree. You need to take the width as 2:1, and then you take a simple deform. Actually, this is solidified. So select the mode. Yes. I'm going to select the simple deform and shift D, and I'm going to rotate another axis for. So this is place. I need to Z. Why is it still Z? Oh wait. I'm actually getting confused. So we have the 380 degree, and then I'm going to bend. Actually, I forgot. So what's? I think it should be this, but we obviously do not get the right result. So the reason is the width should be, yes, the width should be the length 2:1. Oh, so now we have a sphere. Yes, exactly as what I am imagining initially. You can also change the axis because I do not like the pole pointing on x-axis. I would like the pointing upwards. But I think it's something that you have to decide. I don't know. I think you have to experiment yourself about how it rotates, I guess. And let's length 2:1. It does not really work. Why? Oh yes, now it works. Oh, this is nice. So really, just remember something must be 2:1 ratio, and then you need to decide the axis. Okay, so now we have finished everything. Then this is a sphere. In terms of the cube, in terms of the cube, if you by any chances you would like to know, is that you just generated this mesh for 4 times. So because when we have a cube, so we have 4 faces, and you're going to distribute the same grid over 4 places with different random seeds. I think you may need additional loop for that on top of that. Okay. Or you may not need a loop, but I'm not really quite sure. Actually, I think if you're generating a cube, you need additional loop. All of that. In the iterator, you take a matrix list, and then finally, once you generate all these kind of meshes, we have this transform mesh, right? we put the matrices in. So where does the matrix come from? We have the distributes mesh that can read the information from a cube objects mesh data from the cubes. Take the mesh, then we have polygon modes. We distribute on each eye. Take a 3D view. And you basically distribute the same grid that we have on each of the polygons. Be sure about the size and width and everything is correct for your cubes or other things. Otherwise, I think this is easy. I'm not going to really finish this cube version because I think this is already good enough. But this is really cool. This is really cool. So again, this is a noding, so I don't know actually how much time I actually spent on this. I believe it's a lots of time. Here's a little bit extension of the recording because this is already 3 days later after I first tried this entire whole thing. So this is the sphere, and to deal with the solidify issue, you just get the negative value, then it will expand without any problem. Okay. What I really would like to talk about is actually the color. People might think, okay, these different polygons are separate islands. So you use cycle and there is a node which is called, so let's just take a material. People may think we take the, I think geometry, there is a random per island, but it only works in cycle. We are not going to use that method. There is a better method that it works in eevee. So basically the whole point is use vertex color, but if you add a vertex color and if you change if you execute the node tree, everything will be written because the mesh does not the mesh that's used to generate this entire mesh does not include the vertex color. So you insert a vertex color layer and take a random color. There's multiple random color. One is the node that's from the animation node. I don't like this because you do not have real controls over many different parameters. So I don't use that. I have a preset that I created for myself that you can find if you have the preset library. Next step is I need to find how many polygons I have. You can get a different method to find the polygons, for example, mesh info. Take whatever mesh, they're the same. They do not change anything, but importantly, we are working with polygons, so you use polygon centers or polygon normals to get into iteration instead of use the vertices, and put the color list into place. Immediately, we do not necessarily see anything. Actually, can we actually see? Yes, we do see. And once you put a list of colors, you will have multiple modes like the loop, vertex, polygons. We want to work with polygons, so just type into polygons, everything just work exactly as it should be. So in real shaders, because it was just a view, if you go to the material preview mode, it does not really show up anything specific. So we just simply take our vertex colors, and then you can manage whatever roughness or specular you want. One thing I want you to be sure is that you do not necessarily use this random color. You can use this, I don't know, you can eliminate all this kind of saturation so that it becomes pure white, black stuff. And then you can manipulate within the shader nodes using the color ramp. So whichever method you want to choose, it's the same. I have a rainbow color ramp. I made for myself. I don't know what it does in this case. It's just a rainbow color ramp. So it's very ugly. Oh, it's hurting my eyes. So you probably would like to make a better color ramp for yourself. But basically this is it. Play around the values, and I hope you enjoy the whatever tutorial or whatever stuff. So if you would like to have a better tutorial for this version, whatever stuff, please comment below. I will think about that. But I really think it's, although this recording is kind of whatever chaotic because I don't know what to say, but I think it makes sense if you follow through. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.